For these videos, I'm not going to work the integrals all the way through. I'm just going to help you get started and know what to substitute. Okay, so if I'm looking at the integral of 9 sine to the 4th x cosine to the 3rd x dx, I see that the cosine has an odd exponent on it, which I know means I can keep a cosine. So I'm going to write this as the integral of 9 sine to the 4th x times cosine squared x times cosine x dx. All I've done is split up cosine to the 3rd as cosine squared times cosine. Then I can use our Pythagorean identity to replace the cosine squared x by 1 minus sine squared x. Now everything here has signs, so I'm going to choose u to be sine of x, and then du is going to be cosine of x dx, which I see right here. Again, let's just get to the point where we can do a substitution. Here I see that sine has an odd power, so I can keep sine to the 4th of 2t, cosine squared 2t, and then keep the last sine of 2t here at the end. Okay, remember sine to the 4th I could write as sine squared squared, and I'm doing that because the Pythagorean identity will allow me to change the sine squared into cosines. So this is the integral of 1 minus cosine squared of 2t squared times cosine squared of 2t times sine of 2t dt. And then I'm going to let u be cosine of 2t, so du is negative 2 sine of 2t dt. So the sine of 2t dt here is going to be negative 1/2 du. Okay, one more. I have the integral of sine squared theta d theta. What I'm noticing is that I do not have either a sine or a cosine with an odd exponent, so this is the time that I need to use those power reduction formulas. So the power reduction formula tells me that sine squared theta is 1/2 times 1 minus cosine of 2 theta. Okay, now this is just a trig identity. It has nothing to do with integrating, except that I can move the 1/2 out front. Okay, and then I know an antiderivative for 1. I can figure out an antiderivative for cosine of 2 theta. If you want, you could do a substitution with u equal to 2 theta and go from there.